All right, so welcome everybody. Again, today's session is data calculations in ARM. So taking our recorded data, whatever assessments you performed, and talking about kind of what we can do with it to summarize that data. And we have a variety of transformations, action codes, different things that you may want to do to utilize those raw values to create calculated columns, convert yield, things like that. And so you can see we kind of have a long list of items to cover. So we'll dive right in here. So we'll go kind of back and forth, the structure of today's session. I've got a PowerPoint presentation kind of set the stage for each of these topics or types of calculations we can do. So we'll kind of talk about the theory and what ARM has for it. And then we can switch into ARM and kind of actually show it in action. And then we'll just kind of continue to walk back and forth between those two. So I've got this presentation. I also have a trial open here that has a bunch of those calculations kind of rigged up for us. So, so we'll start with the first one here. Excuse me, the first one is subsamples. So if you have an assessment where you're taking more than one data point for each plot, then we put those in as subsamples in ARM. And there's a few different things you can do with an assessment that has subsamples in them to really summarize those subsamples. So here on the screen, I have a few action codes listed here on the right. So these will be the actions we put into ARM to generate a new assessment column in the editor that gives us a calculation based on that source data column. Just to visualize that in ARM before we get into the specifics of those calculations. For example, here in my column number 3, oops, clicking in the wrong spot. Column number 3, I have a assessment where we sampled 5 different leaves. And so we have 5 individual values here in column 3, but we want to create some calculations here based on all of those values. And so we're going to get a single data point for each plot based upon what was recorded in those subsamples. And how we do that then is to use the ARM action codes row to put in these particular action codes, which tells ARM, gives some instructions, in this case, on what to fill in for this particular data column. So looking at the ones we have, the first type would be, just summarizing those subsample values. You can either get an average, so you would kind of get an overall plot average using the TAS action code, or if you, instead of wanting the average of those different subsamples, maybe you want to sum them. If it's, a type of harvest, for example, where you want to know the total across those 5 different subsamples to give you that whole plot total, then the TSS would give you that calculation. If you're looking more for an incidence, really, which would be a percentage of the subsample values that are larger than a particular number. Depending on the type of assessment, maybe you care about whether the values are larger than 0. So anything at all, if we're counting insects, anything that has 1 or more insects, on that sample should count as having that presence of the bug or the disease or whatever. Or maybe the key value is 1. If there's more than 1 of whatever you were counting or looking at, then that would be considered, a source of your incidence. You would choose either TIO for the 0 or TII for the 1 for incidence with 0 or incidence of 1. And that there, I think we had an example. That was my column number 4. We did the incidence relative to 0. So just to look at the numbers, I had 20, 50, 0, 10, 50. So there was one value that was a 0, that we didn't have any presence of the disease, I think in this case. So we ended up with 80% of those 5 values had incidence of the, whichever disease we were studying. So that's how that value would be calculated. And then the third type of subsample calculations we have would be counting values, counting how many values would be in a particular range that we care about. So to some extent, this can be kind of similar to the incidence where this is kind of hard-coded as anything larger than 0 or larger than 1. But in this case, you have control over what the range is. And you would actually specify that when you're defining your action code. So my example here, kind of an arbitrary thing, I think, but here we wanted to count how many of our source column, how many values were between 50 and 100. Maybe for us, there's just kind of a cutoff of, if it's more than 50%, we have a concern. So if you have some sort of threshold like that you really care about, you can create that calculation here. And so, for example, this same first plot 101, we had 2 of them that hit that 50 threshold. So we have our calculation as 2. Whereas this next plot, everything was smaller. There's almost no presence of that disease, so we ended up with a 0. So you can create this calculation based on the subsample values. Real quick before we move on, I have been talking about simply just hand typing in these action codes. You can also find them in the list. So if you bring up the list of action codes, it's a very long list. There's quite a few different things you can do in the action codes field, but there is a section for transformations. So here's where you can find some of them, average the subsamples, some of the subsamples. There's our incidence. So there's a few different ones you can find here that will start that calculation for you. And typically then ARM will just ask you for the parameters. The incidence, you only had to give column what. ARM will just ask you what column are you trying to calculate an incidence from. The range here would ask you 3 questions. What column, what's your range, the lower value, and then what's the upper value for the range. And ARM will just ask you if you select that from this list. And there is one more location that you could add one of these calculations for. Typically, I say click into the source data column that you plan to create, and then under Tools, we do have a transform option as well. So this is kind of pretty much an interface version of that action codes list, more or less. You may kind of recognize a lot of these titles here kind of match the descriptions of those action codes, but kind of a little more simple, kind of a menu, if you will, of what options you have in maybe a more readable format. What is it you want to do? So here's that grouping we talked about right now with the subsamples, and we'll get to some of these other options as well. But it's pretty simple. Click and choose what you'd want. Tell ARM what is your source column number. In this case, it was column number 3 is the one we want to calculate from. And then what data column number should we store the data in? And ARM will default to the next open one. So the very last column I have, that's the first one that's open is column 21. So it would put this subsample average into column 21. I'll just do that to give an example here. And so it takes that source column, all of the descriptions that would make sense to copy, kind of get copied over here as well. And then we get the action code there and the calculation of of whatever transformation we chose. So that's kind of the process for adding some of these transformations here. All right, that about does it for the subsamples. Moving to the next category, this would be control corrections. So this is a pretty popular one, I think, of course, depending on the type of research that you're doing. But really, the goal is that we're wanting to determine the efficacy relative to whatever untreated check that you may have. And specifically, in this case, we're referring to the percent of reduction. So you're thinking that your check is 0. The check did nothing at all. And then all of your treatments were calculating the efficacy of that. How much did it reduce the disease pressure or the insects, whatever it is you're studying. We went out and took some sort of source data column to see how much is out there of that thing that we're studying. And now we want to calculate how effective was my treatment, was my product compared to doing nothing, essentially. And so the first thing to check before really creating these calculations is to make sure you define the untreated check in your trial settings. So in your window settings treatment tab, there is this option here to tell ARM which treatment numbers are the untreated treatments. And here in my study, if I go down to my settings here, treatment, I do have treatment number 1 is my untreated treatment. So fairly straightforward, but certainly if you had it in reverse order and treatment number 6 was the untreated treatment, or maybe you have 2, so you want more checks throughout your field, so you actually have 2 different treatment numbers that are your untreated, you can type in more than 1, just separate them with a space. And in that case, in some of these calculations, ARM will typically take the average of those 2 or more untreated treatments as the source for your calculation. But we'll keep it nice and simple in this case with just our treatment number 1 that we work with. So that's the scenario that we're talking about. And really the most common for this situation would be to calculate an Abbott's transformation. And so that one, really the target is an infestation assessment on a uniform population is really the main target for that calculation. But there are a few variants, I guess I would call them, slightly different ways to calculate this Abbott. And that therein kind of lies some of the confusion on how to accomplish this. And so I've tried to summarize them here in this table of the different options. Number 1, what code we use in ARM to create this calculation, and the differences of really what the difference is in the calculation. So the first one is the tab, kind of your classic Abbott's. We're calculating that the percent reduction. We're calculating it from the check within the same replicate as whichever treatment, whichever plot that we're calculating on. And so that's per plot that our basis is. So each plot is going to have a different value. It's going to be looking at calculating us a unique value for each plot in that calculation. Compare that to the U-tab transformation, and the difference there is we're looking at not the check in the same replicate as our plot that we're calculating from, but instead we are going to calculate relative to the mean of all of the checks across all the different replicates. We're still calculating one value per plot, but really the goal here is if your check has a lot of variation across the different replicates, then maybe we're safer to take that overall average of those checks to kind of minimize the extremes that we would get otherwise. If, oh, well, the check happened to be low in this one replicate, well, then our Abbott's calculations are going to be all kind of skewed, if you will, in that one replicate, whereas, the next replicate beside there was tons of pressure. And so now all of the calculations are pulled kind of the other direction. So if there's a lot of variance there in your pressure, in what the check had experienced, then you might be safer to use the U tab to say, all right, well, let's try to minimize that variability, roll that all into an average of that check as the basis for how we're going to calculate our percent or our efficacy. Finally, if we go one step further and say, well, now we're really concerned about variation across the whole trial, not just in our check, but even in the treatments, and just really the entire trial really had a lot of variation, then we might want to turn to the T tab, and that really is going to take a mean of your treatment and compare that to the mean of the check in order to calculate our percent reduction. And so when you do that, now we don't have unique values for each plot, but we're really only getting one value per treatment in this calculation. So that might be valuable because of that variation. But one thing to note, the column itself then, having that in a column in ARM is maybe a little challenging to, it takes up space and it doesn't provide us a whole lot of information. So let me just, for example, let's grab that at T tab and do that based on column 1, just to show that if I sort by treatment, you can see that each treatment has the same value. It's just repeated. So there's no variability. If we were to run this column through AOV, the analysis is kind of going to shrug at us. There's nothing here to look at. There's no variation. There's nothing to do statistically. So so it might not be something that you really want to have a whole column devoted to that. But if these values themselves are kind of useful, you can actually use this APC action code in that source data column. And this is an automatic percent control, meaning that when you run the AOV analysis, it'll perform that T tab essentially and just report that on the report. Let me do that real quickly here. File, print reports, just to show that I want to use only the data columns that I currently am looking at. And we'll have that right there. So if I preview, let me see if it'll show our columns. No, it won't. I got a preview on the full screen, which will be fine because it'll be a lot easier to view as well. So we're looking for column number 20, or no, column number 1, actually. Let me zoom in a little bit in case it's a little small, but just real quickly to show that column 1 was the original data column with the data we took. So we have our treatment means here based on those values we recorded, but with the APC present in the action code, ARM prints these percentages. So we get to see that T-tab calculation, our efficacy for each of those treatments just kind of on the side. You know, we didn't have to put in all of the statistics, which is what this would look like here. Column 22 is actually that very same calculation. You can see that really is that percentage value. It's just maybe not quite as clear. I could have, you know, put in a nicer description to at least explain it, but you have this whole separate data column now where there's no statistics that can happen, because like we said, there's no analysis to be seen. And then you get this where it could not calculate LSD because the error mean square is 0. You know, there was no statistics we can do. So that's kind of the pros and cons of those two options. Basically, you can get those T-tab calculations, but just squeeze them onto the AOV report by utilizing that APC. All right. So that's a tough one, but hopefully trying to lay that out a little bit as to the different layers of an Abbott. So, you know, it's a very common, I'm looking for the Abbott calculation, but it isn't maybe necessarily just cut and dry, click a checkbox and there's Abbott's. You may want to look at the trial that you have and see what would be the appropriate choice based on what this trial is experiencing. In order to really get the right type of Abbotts for that trial, for that scenario. Kind of along the same line with the control corrections and calculating efficacy, there are a couple of other types of calculations. Again, largely depending on maybe the type of research you're doing. Certain industries will say, well, everyone uses Henderson-Tilton instead, or what have you. So sometimes that's the key, is the type of research you're doing, what type of calculation you may be looking for. So we have a Henderson-Tilton is available in ARM. The code would be THT. You notice there's actually two columns we choose for there. And the key is when you have a pre-treatment assessment that you want to adjust for. So typically this is used for like an infestation rating. If the population isn't uniform, then let's go out before we make any applications and get kind of a baseline assessment that you put in as a column, and then we'll make that application, come back and see what happened. And so now you have basically two data columns, and so we are utilizing both of those to calculate that Henderson-Tilton. Lastly, on this section at least, the Schneider-Orelli, that's TSO we provide, and that's a mortality rating. Again, kind of assuming a mostly uniform population for that one. So kind of still under the same umbrella of control corrections, we first, with the Abbotts, we were looking at the efficacy, really thinking the check is doing nothing. So the check is 0, and then we calculate relative to that. The flip side of that would be a percent of check, where the check is 100%, and then we calculate all of the treatment performance relative to that 100 instead. So kind of a similar boat, I guess you can say, as the Abbotts, but obviously a different calculation because those numbers will be different. And we have a UPOC and a TUPOC, I suppose, would be the two transformations we have. Kind of similar to before, you're trying to decide what check value should we be calculating relative to. And so we can either calculate just within our own replicate in that same rep what was at the check. And so you get, we get a unique value per plot like we did before with the Abbotts. If the check is consistent, we feel good about that, that we can use the individual replicate values. And that pretty much matches up with our discussion with the Abbotts, the tab. We kind of don't have that middle option that we saw last time, but if we think about the third option at the bottom where we were doing the T tab, then we have that same issue. If we're concerned about a lot of variation across the trial, now we maybe need to take just the mean of our treatment versus the mean of the check. And so we're only going to get one value for each treatment as that percent of check. Kind of just like we saw with the T tab. Same exact thing as before with the special action code. We have an APOC, so automatic percent of control. Kind of will do the exact same thing. So if you want to use the original column and put APOC, you'll get that same percentage on your report when you run the AOV report without having to create kind of a separate column with that value in it. So again, just depending on, are you looking at efficacy where the check does nothing, check is 0, and we calculate from that, or are we looking where the check is really 100% and you're going relative to that? How much did we reduce things by? 100 down, it's 80% left, it's 20% left, whatever would basically be your calculation there. Again, those are all added again through the action codes. And a lot of times I'll just do something like filtering the description. If you want to kind of try to remember all those different options, just do a right click and filter for, and I'd probably just search for the word control. Or if you are looking for Abbott specifically, Abbott's might give it to you, but just getting a filter then can kind of limit down our options to what we've been kind of talking about here, if you're trying to find it in the list. All right, a lot to unpack there, but that would be our control corrections. All right, moving on to yield conversion. So we have a tool within ARM to kind of help make yield conversions. The assumption being that you have your raw weight. Let me switch over to ARM here, I guess, and we can talk through maybe the source data columns that you might have. So typically your yield in some raw weight, in my case, I've got them in kilograms from each plot. And perhaps you maybe have a moisture content, kind of a moisture percent value for each individual plot. Or maybe you have a whole trial average, just depending on your situation. But that would really be your source information that we have. And we want to convert this raw amount to a more standard area basis. In my case, I'll end up with a tons per hectare. You might be looking at pounds per acre if you're using the imperial system, but we have tools within ARM to calculate that conversion for us. So you don't have to memorize any formulas or anything, but instead we kind of have an interface to go through to create the right calculation based on a few different parameters. I guess, sorry, switch back in ARM just to show that you can start this under tools, and there's a convert yield. And I'll go back to these slides here just to show kind of the same screen here, but kind of the main spots to look at. You tell ARM what you have in your source column, what unit. In my case, it was kilograms. is what we recorded the raw weight in. Then we say what is our desired unit. In my case, it was tons per hectare, but we have a variety of options. You can calculate kilograms per hectare, pounds per acre, bushels per acre. It's quite a few different source, that we can calculate into, depending on where you're trying to get. The next set of options here would be your plot size. So if you harvested the same plot size throughout, then you can type that in here, width and length. If each plot had the exact same area that was harvested, we start with your plot size, the treated plot size in your trial settings. But if for some reason it's smaller, you only do the middle 2 rows or something like that, you can always just adjust that right on the screen here to choose the plot size specific for the harvest. Or alternatively, if for some reason some plots had a different area than others that you had to harvest for whatever reason, you can actually turn that on and choose a particular data column where you put in your widths or your lengths or both. So that's a good way. If there are custom areas that you had to harvest, you just put those in as a separate column in ARM. These are my widths, or these are my lengths, and then ARM can use those data columns. So depending on which plot you're in, it'll calculate with a different area, essentially. Then the last kind of section of options here would be the moisture adjustment. So you can adjust to a particular dry moisture percent that you can specify here. It'll also pull, I think, from your site description if you had that filled in already. And then you can choose either that whole trial average. If you have just a trial average of your moisture at harvest, you can fill that in by hand, or you can choose a data column number that has that moisture. So in my case, I had that moisture content that came with when we did the harvest. So, each plot had a slightly different moisture percent. And so I can have that factored into my calculation as well. So again, that was tools, convert yield, to bring that tool up. And here in that case, I was using the percent in data column number 7. Is we can specify particular columns to pull that information from. So once you've filled in those sections, and certainly if you don't want the moisture adjustment, there's just a little box, you can turn that off. And then this whole section will go gray because we won't adjust for moisture. But in the end, then ARM is kind of constantly updating this yield conversion factor. And so that ends up being what we would multiply your source kilograms, in my case, by that yield conversion factor number to create your converted yield in a new column. And so that's what I had here is my kilograms per plot, factoring the moisture, then I ended up with a yield in our tons per hectare. If you have a trial that already has this converted yield, but maybe you're not totally sure kind of what went into it, or wanting to kind of double check the selections that were made for it, if you click into that converted column and then repeat that command, tools convert yield, ARM will do its best to fill in some of this information. It doesn't always save all of it, but it can at least kind of give you a start to see what it does. In memory, it really is saving. There's this TY1 action code that gets added. And so within memory of the trial, it's really just saving that conversion factor and maybe which data column we were referencing here in our moisture adjustment. So it might not be able to rebuild everything for you, but it's, in this case, it's pretty easy to guess. Here we can see we have the tons per hectare, so we must have had that choice there. So then we can see that true yield conversion factor of what was done to get those values. So you can somewhat reverse engineer that calculation if you need to, if you're curious what was done to get that yield calculation. And again, just to reiterate that TY1 is really how ARM is saving that in memory to remember that there was a yield calculation that was created. Okay, so that would be yield conversions. The next topic are the EPO rating scales. So a 1 to N, we'll call it. You know, most all of these, the same idea applies whether you're doing a scale from 1 to 3 or a scale of 1 to 9. You know, however many different sections you've maybe split up your assessment by. We can do similar calculations with them, and so I guess there's a couple of different ways to put in an assessment like this into ARM. And then depending on how you're filling it in, we can calculate information. We can kind of get the same calculation in the end, but just depending on the format of how you filled in ARM, we might use a different calculation, a different code, I guess I should say. So my example here, I have a leaf disease, leaf damage from 1 to 4. So, we're looking at, 25 leaves on our tree. Maybe our plot is a tree out in an orchard or something. And so we're going to look at 25 different subsample values, 25 different leaves, and give it a severity rating is, from 1 to 5, where I think in this case, 1 is the best, there's no blemishes, no nothing, it's perfect. 4 is, tattered and pretty much toast. Whatever type of system you're using, there'll obviously be some defined categories of what looks like a 1, what looks like a 2, et cetera, et cetera. I think I've got a typo here in my box. This should be category 1, but so that would be the type of assessment we're doing. Then the question is, how are we recording that assessment? Here on the screen, what I've done is kind of a tally mark system, more or less, where I would tally up anytime I have a category 1, I would put a tally mark down. So in the end, after I've done all 25, I think in this case, 3, 6, 7, 8, 9. So maybe I've got 10. Maybe I've got 10 leaves in this case, perhaps. Once I'm all done with looking at all 10 of those, I see that 2 of the 10 leaves were category 1, and 5 of the leaves were category 3. 1 of the leaves was category 4. So I kind of have the total number of leaves, in my case, that were in that category. And that's really how I recorded those values. So I end up with, in my case, 4 different assessment columns in ARM, giving the number, the count of those in that category. So if you're doing things that way, we have a couple of action codes in order to calculate a pest severity. Like it could be whatever you're studying, the severity of that assessment, and also an incidence, a percent incidence calculation. And so that severity for example, here I've got the at EC 1 to 4. That really is a weighted calculation. So if we look at this calculation that's behind there, it's taking the number of leaves in category 1 and multiplying it by 1. The number of leaves in category 2 times 2. The number of leaves in category 3 times 3. So the worse off it is, the larger we multiply that value by. So it's more severe, it gets a bigger weight to that value. And then we finish it with 4, the number of times the number 4 times 4. And then we divide by the total number of values that we have. So we're giving more weight to those leaves that are really severe, that really had a lot of disease or whatever we're studying. Oops. So that calculation is kind of giving weight to those more extreme values. And so we get a severity value in the end here based on those previous 4 columns. We can also calculate that percent incidence. So that's really just anything, in this case, it's anything that wasn't category 1. So category 1 was basically untouched, totally pristine. And then we count anything else, the 2s, the 3s, and the 4s in this case, divide by the total number and then multiply by 104%. So this basically gives us how many had any sort of incidence on them, that they weren't just perfect, that initial value. So just to visualize that here, just like we talked about, I've got our leaf damage, and we just had 4 columns to put in those numbers of how many leaves fit into each category. And so then we're able to calculate the EPO. Let me clear out my filter here to show. There it is. So our action code EC14 is our EPO rating scale from 1 to 4. So you can see we have one for pretty much every combination, 1 to whatever, 1 to 2, all the way down to, I think, 1 to 9, even 1 to 10, 1 to 11, and 1 to 12 is kind of the top one there. So that gives us our severity, and then this DIP 1 to 4 gives us our incidence. Kind of the same situation here in the action code. We can go all the way up to 12 for a 1 to 12 scale. So looking at this slightly different, still this more or less the same scenario with subsamples, but now instead of having different columns for the different categories, we instead have just one assessment column. And we're putting in that scale. In this case, now I'm doing a 0 to 3. And so let me switch this over here in ARM to show the difference. We can still be doing some sort of pest severity. In this case, it's damage to the entire plant from 0 to 3. And so I have 10 subsamples here, and I'm just recording that scale value. Okay, this first plant was untouched, it's fine, it's a 0. The next plant is pretty beat up, it categorizes as a 2. So we have the actual category value recorded for each subsample. And so we can fit everything in one assessment column with those subsample values. So if we do things that way, we can calculate the same weighted pest severity and the same percent incidence. So it's really the same calculation, the same end result of what we are trying to find out, that very same system of weighing out the severity we're only counting those within the right range, but we're doing it just on that single source data column. And so if I go into ARM, you can see we used at DS04. And so we have, for some reason, I only did this on our untreated values, but that's okay. So you can see the calculation there for the severity and also the incidence based on the subsample values in that plot. And just a quick note that some of these are missing. So if you have it empty or a missing data point, the incidence then won't count it. So it won't count as a 0 because it's missing. So that, a missing is different from a 0. So you can see in this case, we have four zeros, 4 non-zeros, and then 2 that were missing. So the correct incidence calculation would be 50%. Half of the recorded values were not 0. And so we get a 50, even though there were 2 that were missing. So again, the kind of the importance of as you're filling it in, if you don't have all 10 values, I think the best way is to put a period, so that way it's clear that you specifically don't have a value there. But if you left it blank, ARM will do the same thing. In any case, that 50 is the calculation there. Just to show that list here, same thing. We've got disease severity 04, 05. I guess we don't have every single combination, but definitely if you would use it, send us an email. Like if you're looking for the 0 to 7 and for some reason it's not in this list, we have a DIP 07, for some reason not the DI 07. So if you have one of these scales that it just doesn't have the specific one you're using, send us an email. As you can imagine, it would be pretty straightforward for us to come up with that calculation. It'd just be a matter of adding it in. And it's fairly easy. We can get that out fairly quick. It just comes in that dictionary update most often within ARM. So that's kind of the two different systems for the rating scales. I'll admit I don't totally know. I just refer to this as non-EPO, whereas that last list we had the EPO title. I don't know the history of that. I just know that's how we have it labeled in ARM. So I'm not sure if this was like the standard way, EPO described. And so that's how it got, that's how EPO got its name within ARM on those calculations, or exactly what's behind the scene there in the naming. I'm not real sure of that history. I just kind of mimicked what we had in ARM, and there was no, these are kind of all the other rating scales that didn't have that EPO designation to it. So I kind of just, lack of a better term, led me to non-EPO in that case. So maybe there's a better name out there for those, and I'm just not aware of them. But okay, last topic. Might be the most useful in some regards. And we could actually fill a whole hour worth probably on the different things you could do with this section. But I leave it towards the end for me to keep it brief. But really what this is, we call it a user formula within ARM. It's basically like Excel. Pretty much everyone's familiar with Excel. You just hit the equals button in a cell and start to type an equation, and Excel will calculate something for you. That's basically what this user formula is. So in ARM, if you have a source data column that you want to create some sort of calculation with, then you can use tools, transform, like we did before, and we've seen some of these examples here, but down near the bottom, there's a user formula. And when I click on that button, that kind of hides all of the other options away and just gives us that text box, just like we have in Excel, where you can type in your equation. What do you want to do? So to talk through some of the options you have for how to fill in that formula, the first one is to use another data column, which would probably be the most common. I want to sum column number 1 and column number 2 together, for example. Then you would use the bracket. So this here bracket with the number 1 in the middle will take whatever data is in column 1 and then do the addition in this case and add it to column number 2, for example. So that's how you can refer to a particular data column in order to manipulate them. That yield conversion we saw a little bit ago would be something kind of like this. It would be, that column number 1 times that, conversion number that we had, or something kind of like that, is basically what that yield conversion did. Referring to the source, column number 1, and then doing some sort of mathematical operation to it. And then we'll put that, those calculated values into a new assessment column. We do have different functions. So just like in Excel, where you can put the @ sign and have some sort of some function that'll do some more complicated calculations for you. We do have some of those available. Kind of the easiest way to see those when you're here is to press the F1 help button or the help button here in the corner. So if I press F1, it takes me right to the data transformation formula and gives me a list of items. I think if I press this help button, it does take me one step back. So it's showing me how to use all of these different buttons, but it's pretty easy. If you scroll down to the bottom of this first table, there's a user formula. You see, I go there a lot to remember what I can do. And it takes you to this data transform and talks through, the mathematical signs you can use, the functions, their absolute value, calculating sines or square roots, different things like that. So this can be helpful. Average, count sum, different functions available to you. Again, that was the F1 help, or the little help button in the corner. There's a couple of options at the bottom of that dialog. I'll go back to ARM just to point them out. You could limit calculated values to positive, or if you're doing subsamples, you can make sure to calculate only one value per plot if subsamples are present. And so typically what it would do, and that was exactly in my case, you can see I've got subsamples. So it'll typically take the average of those subsamples before doing whatever calculation that we defined. And the limit calculated values to positive, if you're doing some sort of calculation, maybe it's if it's an efficacy type of calculation where you really would not want negative values, like, okay, I'm doing something relative to the check, so it would make no sense that my treatment was actually worse than the check for whatever you're calculating. This would be a way that ARM would essentially truncate the calculation, that instead of it being a negative 2.5, it would just override that negative and make it a 0 instead. Might be something to use with caution. I guess, statistically, you want to make sure it makes sense what you're doing with that type of calculation, because, just truncating and changing the way it's calculated might not be the best thing, but in certain cases, it might be what you would want. So just wanting to point that option out. Finally, if you're using calculations, just kind of like you're wanting to do something relative to a check, you can refer to specifically the untreated treatment with the TU code. So for example, and I added the C1 is the same thing as up here when we did column 1. But I put that C there to make it a little easier to understand the difference. This is referring to the value in column 1 divided by the value in column 1 of the untreated check. And then we multiplied by 100. So some of that, it would be the logic that we deploy in those Abbott's calculations we were using earlier. Some of that logic of being able to pull in the untreated check. So, really the sky's the limit on those formulas. When you define a formula and you say, okay, to put something in, what happens here, this column 20 is calculated from column 19, and ARM puts in a T1 or a T2 in the action code. And so ARM will remember the transformation you defined. If you want to know what this T2 is, you can just click into that column and go to Tools Transform, and ARM will show you what that T2 means. So here in my case, really, really simple. We took the values in column 19 and multiplied it by 2. There's this drop down here, so you can actually see all of them. I also have a T1, which it looks like that would be our yield calculation. It looks like it's adjusting for moisture and all of that. So you can see the full list of all the different calculations. And yeah, question here to confirm, you're exactly right. That TU is referring to the untreated values in column 1. You're exactly right. So if we were, so you would have that kind of that percent of check idea of whatever value you have in that source column and then divide it by the check. Well, if this is already the check, it's going to give us 1. It's going to give us 100%, which is what we'd expect. But if we were in column 2, then this 80, we would have 80 divided by what's the value of the untreated check in column 1, which would be 10. So 80 divided by 10 times 100, would be the value we would end up getting. So that can be useful as well. We're almost out of time. Just real quickly to show that there are some more advanced things you can do with formulas. I would say, keep it simple at first. If you haven't used the formulas before, they can be simple and straightforward. Like I said, we fill a whole webinar full of using some of these. But once you get comfortable with those, just know that there are some fairly complicated things you can do. You can get pretty sophisticated with some of the formulas you could define, a lot like you can do in Excel. Just know that, a lot of this is described in that help topic. Or if you have a desire of, boy, it'd be nice if I could calculate this, that can be a great thing to send into support, and we can kind of help you craft the formula you might want. But there's things you can do like using a header field from your column. So a common one would be like your sample size. If you needed to divide your total by how many values you were taking, you could pull in the sample size value from your column. If you're doing something like an AUDPC, you can use a match statement to automatically find certain columns to bring into a calculation. So my example here, averaging all of the columns in this trial that have a rating type of bricks. And so you would grab all of those columns together and then perform an average on them. And then there's a prompting even. So when that transformation gets defined, ARM will pop up and ask you to fill in some particular input for that trial, and that would get baked into the transformation. So we won't show any of those. We've kind of hit our time limit here, but just wanted to give a flavor of what can be done if you need. So that's everything. We went pretty fast and furious. through these options, but hopefully at least kind of raise some awareness, if nothing else, of what can be done. Feel free if you find yourself wading through that very large action codes list or trying to remember some of these things, always send us an email and support, and we can help you find the right direction. I have a minute or two if anyone had a question they were holding on to the end, but I don't want to hold anyone hostage since we've met our hour. So I want to thank everybody for joining us today. Hopefully, maybe you've registered for some of our other webinars this month, and we'll be seeing you again soon. But thank you all for joining.